それでは皆さんよろしくお願いします。
Thank you very much for your kind introduction. I am Terabe from Sumitomo Corporation. What I would like to do is to talk about exciting future generated by exciting quantum computation technologies. I hope my talk will stimulate some discussions amongst all of us. Now, Sumitomo covers from underground to the outer space. We are a conglomerate. So these different fields can become test fields for quantum computing, which can transform the entire world. So we call our project Quantum Transformation. Here's a brief introduction of myself. I've been studying quantum computing for 7 years. I used to be an automotive engineer. Now, quantum computer is something that really puzzles you. What is it? Is a question everyone has. But I wanted it to be connected to the society. So I've been communicating to the public, and I have published some papers since I'm an engineer. Now, I talked about the large expanse of the coverage of the company. We have 900 business units at Sumitomo. And of course, this list is not exhaustive, but I hope you can see the coverage is great. And in some of these areas, we have started some demonstration projects of quantum computing. Now, how are we looking at quantum? As Onishi-san mentioned earlier, when the world changed from analog to digital, we saw some new industries coming out of that result. Now, quantum is a new computation methodology, which therefore will have a transformational impact. Thus, quantum transformation, the name of our project. Now, in 20 years, the industry will have a very different look from now because of new applications which we haven't yet to discover, the applications which can come out only from quantum computing. In chemicals and in finance, quantum computing can have profound impact to different domains of the industry. We are now looking for the treasure trove, so to speak, that quantum computing promises. So, here are the ways quantum computing can be used and the applications. So, we define application and we model in quantum and we have the runtime. But the problem is, what can we use it for? We don't have people who can handle it. We don't have sufficiently mature hardware. So, in order to resolve all those challenges, we have been doing a lot. And we are focusing on building use cases the most, because use cases are all about building new industries. So, application development is being done in collaboration with universities and other companies. Now, in the middle, the lack of talent or human resources, it's so difficult to use quantum computing. Why don't we build technologies to make it easier? Well, Classic from Israel is the one who's doing that. You heard their presentation yesterday, and we are investing in them. And our group company, SCSK, is developing AI quantum platform. Now, I also teach at Tohoku University, and I have launched some talent building programs there. At the bottom, the hardware has to evolve. Nord Quantique is a Canadian company, Canadian startup, doing superconducting quantum hardware. So we are collaborating in various fronts to make quantum computing a reality. So let's start with the application development. And this is the vision that we have at Sumitomo. Towards the very left indicates the businesses that Sumitomo Corporation has right now, and toward the right-hand side are the exponential future, which can be realized only by quantum computing. This is our vision, so we envision the world to be like this. We want to strive to realize the right-hand side. So, the vision of the future is but now backcasted so that we know what to do in order to achieve it. But this appears very ambiguous and vague, and to some it looks only like sci-fi. So, we really have to make sure that the technologies are used in applications. From the status quo, we are in the stage of applying a bit of quantum computing to some hard problems that we face right now, so that toward the very right side, we will lead to some continuum of the technologies continuously being used. Let me give you an example. Quantum Sky Project. In 20 years' time or 30 years' time, quantum computing may become a norm. And what society will it bring? We are currently developing the urban air mobility vehicles. In 10 years' time, in 20 years, there would be flying cars all over, flying vehicles. Actually, toward the end of 2020, flying vehicles will be commercialized, carrying people in the sky. And we are sure such a transportation mechanism will be there in the time of quantum computing, because quantum computing is used to control the air traffic of these vehicles. Now, OneSky is an American company which has the highest level traffic control system, and we invest in this company, which also has some work with NASA as well. My video system failed. I'm sorry. I thought I would be able to show you a video here. Now, as you see at the bottom of this slide, there is a simulator. Quantum computing is used to optimize, to maximize the number of flying objects. Last year, presentation was made at an international conference. Now, flying car may not be able to fly when the wind is too strong and there is no radio communications. And at the speed of 200 kilometers per hour, the traffic has to be optimized real time. And quantum computing was used to increase the number of vehicles that can be airborne at the same time. I hope you will Google YouTube to find the video. So, such problems have been translated into graph problems and have been implemented, actually. So, we are working with people who are also excited with the future. Now, let me change a gear a little bit here. Have you seen this headline? AI can do great things if it doesn't burn the planet. Sound rather edgy. Actually, the power required for AI increased 300,000-fold from 2012 to 2018. And 10% of the global energy is used in learning of AI. So AI, the current AI, doesn't seem to be very sustainable because of the power consumption. How about quantum computing? D-Wave is the only one that publishes numbers. Now, QPU of D-Wave is 20 femtwatt. Femt is 10 to the power of minus 15. So nearly zero power consumption. So quantum computing, if quantum computing can realize AI, we may be able to build a sustainable AI society. That's the idea. Now, Sumitomo has also a business in financial services, especially futures trading of commodities. So we have applied quantum AI to such problems. We are trying kernel method for gated QC and Boltzmann machine in quantum annealing. When it comes to energy, in the future, renewable energy like wind and solar will be more widely used. We also have power generating businesses and power selling businesses as well. So carbon neutrality is of a great interest to us. On the other hand, photovoltaic and wind are affected by weather. Today it's cloudy. PV won't produce much electricity, but we cannot tolerate the power outages because of the weather. So we have to expect some mismatch between demand and supply, which have to be very fast optimized. So a temporary solution would be to use hydrogen storage. We may use EVs in our car lease businesses. So that's another thing we are doing right now. Going forward, we will see the increased number of nodes. The optimization, therefore, become ultimately very, very difficult. Now, 1 sec or 1 millisecond reduction in optimization time benefits greatly. That's the reason why we want to apply quantum computing to such optimization problems. Now, I've been talking about all of this in the backcasting manner, but now I'll change my perspectives to forecasting. Starting from what we have a company called Belle Maison Logistica, which is a logistical company within our group, and we tried the optimization system. This is quantum-inspired project, not quite the quantum computer itself, but the system was used to optimize the workers' shifts. We built UI. We listened to the people who actually work in the warehouses, and we saw some positive outcome. We might want to build a system out of this experience and roll it out. So, in the forecast context, this is one of the things we are doing to benefit the business. So, these applications and use cases are being built, and we would like to increase them. But eventually, what are we aiming at? This is an illustration of quantum smart city. In different places in the world, we are currently developing smart cities. This is in northern Hanoi. From scratch, we are building a city in the farmland. Since we are doing this from scratch, we can introduce interesting technologies. This city is expected to be completed in 20 years. Absolutely the era of quantum computing. So we cannot design the city based on the current technologies. We have to assume that quantum computing will be used there, and different applications are being POC'd, demonstrated, so that those new applications can be rolled out throughout the world. So that's what we mean by living quantum lab. Now, I talked about applications. Let me talk about software and education. Another challenge that we have. Yesterday you heard their presentation. My best friend, nice guy Neil, presented the company Classic. Gated quantum circuits can be built very easily using their technologies. Well, you may be able to do this manually now, but now as we see the qubits increase in counts, manual work will not be viable going forward. So, automatic optimization offered by Classic will make it easy for even laymen to be able to use quantum computing, benefit from it. Well, so this is a company that we invest in. At SCSK, our group company published a paper the other day. This was about quantum AI simulator using FPGA. As you know, gated quantum computers still have immature hardware. Although IBM is quite famous for it, it's not really industry ready. So they focused on AI simulation. Increase the number of simulations to be able to run, and using FPGA to make it faster, so that they build an environment where they can actually try quantum computing. The algorithm can be built or was built to evaluate fashion tastes, and it seems like the learning is more efficient. With a smaller amount of data, the algorithm can now learn. Because, or rather, when the mature hardware is developed, it will be used. But this is a type of a tool as the interim solution to accelerate researchers in this field. So if you're interested in using it, let me know. Now, in terms of education, we are working with Tohoku University. One of the things we did was we supported the quantum annealing solution contest. We offered an award, Sumitomo Corporation Award, like EV optimization ideas presented by these brilliant students are now being put to projects into practice. So in various fronts, we are striving to build a future, exciting future based on quantum computing. As I mentioned, we invest in Nord Quantique, superconducting quantum computing. The surface code or overhead of 1000 was inevitable in the past for error correction, limiting the speed. So what they thought of was to use bosonic codes to develop ultra-efficient error correction technology, which is used in quantum computing. Now, in order to use bosonic codes, hardware has to be tweaked in many different ways. But they have already launched their endeavors to realize their aspirations. Now, ultra-conducting technologies as well as hardware products are the part of the prowess of Japan and Japanese industry. So we are hoping that we are able to build some ultra-conducting or superconducting ecosystem around Nord Quantique and Japanese counterparts. Now, quantum computing is for the long-term future. As an engineer, quantum is exciting, and I really want to communicate this excitement to others. And together with those who can get excited, we really want to build the future based on quantum computing. So if you're interested, please let me know. Thank you. I thank you for this opportunity.